We are going to be doing a gravity reading. So you're going to need a copy of the gravity reading from our science drawer, and you're going to follow along with me. You're going to need to read it out loud, and you're going to do it as many times as you need to feel confident that you can read this back to me, because then you're going to record yourself reading it back to me. So when you are ready, let's go ahead and begin. Would you be surprised if you dropped a ball you were holding and it did not fall? Or if you threw a basketball at a hoop and it did not fall back to the ground? We don't tend to think about why objects move the way they do every day. One of the most famous scientists to think about why objects fall was Isaac Newton. He suggested that there is a force that pulls objects straight down toward the center of the earth. Gravity is this force that pulls objects toward each other. Newton realized that gravity acts everywhere in the universe and not just on Earth. Gravity has been around since the very start of the universe. After the Big Bang, gravity pulled atoms together to make stars and planets. Once the stars and planets had shape, gravity kept the planets in orbit around the stars. It also keeps moons in orbits around the planets. On each planet that is large enough, gravity even keeps the atmosphere around the planet. What Newton realized is now called the Law of Universal Gravitation. The Law of Universal Gravitation states that the force of gravity acts between all objects in the universe. It works the same way everywhere. It also works on all kinds of different objects of all different sizes. There are two factors that affect the strength of gravity: mass and distance. The bigger an object is, the closer you are to it, the stronger its gravitational pull. There is often confusion between weight and mass. They are not the same thing. Mass is measured by how much space an object takes up or how much matter the object is made up of. Weight, on the other hand, is a measure of the gravitational pull on that object. When we measure weight on Earth, we are measuring the gravitational pull on the objects here on Earth. The moon is much smaller than Earth, so it has less mass. Due to this, the gravitational pull on the moon is less than that on Earth. How does this affect weight? Well, if you were to weigh a bowling ball on Earth, it would be about 7 kilograms. That same bowling ball on the moon would be only about 1.6 kilograms. The bowling ball did not change. The mass is the same. The weight, or the force of the gravitational pull, is what is different. On Earth, all objects are pulled by gravity at the same rate, at about 9.8 meters per second. You can test this at home by taking an empty water bottle and a full water bottle and dropping them at the same time. Both bottles will hit the floor at the same time. On Earth, gravity keeps the air around us and everything else from floating off into space. Gravity also causes things to fall to the ground. It causes the ocean's tides and hot air to rise while colder air falls. Gravity impacts everything on Earth.